For this problem, we have Julio walking from one corner of a rectangular field to the opposite corner, and we're given the dimensions of the field, 50 and 120 yards. We want to know how far Julio walked, basically. What's this distance? Now, a couple keys here. First off, this is the hypotenuse of a right triangle. We know it's a right triangle because they told us this is a rectangle, so this must be a right angle right here. And you could do this with a calculator. I'll show you that in a minute. But you actually could do this without a calculator. 50, 120, this is the beginnings of a 5, 12, 13 right triangle. So if we have a dimension that's 50 and a dimension that's 120, basically you're just multiplying each of the original ratios by 10. That means 130 must be the other side. So that's one way to get to the answer. Now, another way is you could use your Pythagorean theorem. We know that a squared plus b squared equals c squared in a right triangle. And the c squared is the side that we're looking for here. A and b are the 50 and 120. So we have 50 squared plus 120 squared equals c squared, which means that we have c squared equaling whatever these two things added together is. So that means we're going to have the square root of these things. Now, what is 50 squared plus 120 squared? Let me check my calculator. So here I am in my grapher, but you don't need a graphing calculator to do this. 50 squared plus 20 squared is 16,900. So that's my c squared value. Now, to get c by itself, I have to actually take the square root of that number. So in my calculator, I have to do second x squared to get the square root, whatever you need to do on your calculator. And then I'll do 16,900 and enter, which confirms my answer that I had earlier of 130. And normally if you square root an equation, you need a plus or minus, but we don't really need negative distance, so we can throw the negative answer out. So that ends up being choice A. For this problem, we have somebody working at a garden center planting flowers. The first row is going to have 3 flowers, and then each of the rows after that will have 4 more flowers than the previous row, than the row before it. So for example, the first row will have 3, second row will have 3 plus 4, so 7. Third row will have to add another 4 to the 7, so that'll be 11 flowers, and we keep going. Now they want us to figure out the number of flowers in rows 20 and 35. So there's clearly a pattern here. It's an arithmetic pattern because we keep just adding 4 each time to get the number of flowers in the next row. And we want to take it out to 20 and 35. So let me build a little formula to help me out here. So I've got, first off, 3 flowers in my first row. And this is the number of flowers in row n here. So 3 for the first row. To get the next row, I have to add 4 to that. And to get all the rows after that, I have to keep adding 4. So I would multiply 4 by n to find out how many 4s I have to add, but I don't really need to do that because I've already used up one of my rows with this 3 right here. So I actually want to multiply by n minus 1 because by the time we get here, again, we've already figured out the first row. So just to kind of show you how this works, if I plug in, for example, 1 for n, the first row, I would have 4 times 1 minus 1, 4 times 0, this whole thing would zero out and I would just have 3. If I plug in 2 for the second row, now I've got 4 times 2 minus 1. So that would be 4 times 1. 3 plus 4 is 7. So we need this n minus 1 in here to make this work. Now specifically, I want to do 20 minus 1 to figure out the number of flowers in row 20. And I can plug this in the calculator. You might not need to, but I'm going to just because I can. So plugging this in, letting my calculator take care of everything, that's going to end up being 79 flowers in that row. Now for row 35, pretty easy. We just have to replace this 20 with a 35 instead. And I'll go back to my calculator for that. Let me just go up here and use my previous input. You might have to re-enter everything on yours, but mine's a little fancy. We'll do 35 instead of 20. Literally, that's all I'm changing. And now that all comes out to 139 flowers in the 35th row. That's a whole lot of flowers. On this problem, we have a diagram in which they're telling us that triangle MNP is similar to triangle QRP, so similar triangles. And we want to figure out how long this side QR is. Now, since these triangles are similar, that means that their sides are in the same proportion or ratio to each other. So what we can do is set up a little proportion. So I can say, for example, that 2, this is PQ, this side here, 2 over QR, whatever QR is, that's going to give me the same ratio as 5 over 4. So we're just using the corresponding sides of each triangle. And now to actually solve this for QR, I just have to cross multiply. So we have 2 times 4, that's giving me 8 on one side, and 5QR if we multiply the other way. And now I just have to divide by 5. 8 divided by 5, I just happen to know that that's going to be 1.6, but you could do it on a calculator in this section if you wanted to. So that ends up being choice B. For this one, we have a cup in the shape of a right circular cone, and it's filled with water to half its height. We want to know, based off of these measurements, how much volume this empty part of the cup that's not filled with water has in it. So the key on this, first it'd be helpful if we have the volume formula for a cone in general. That's going to be 1/3 of the volume of a cylinder, so 1/3 pi r squared h. And then the overall setup of this, to figure out this white space in here, we need to take the volume of the whole cup and subtract out the volume of the water. So I'm going to call this V1 minus V2, or you could do V2 minus V1. Doesn't really matter. Basically, we need the volume of the whole cup minus the volume of the water. So doing the whole cup first, we've got 1/3 times pi times 1.4 squared times a height of 2.1. That's the whole cup. And now we're going to subtract out the volume of the water here. So that's 1/3 pi times, now we have a radius of 0.7 inches, so 0.7 squared, times this other height of 1.05. Now, thankfully, we didn't actually have to figure out what this came out to numerically, because that was one of the answer choices. Just looking carefully here, it looks like that's answer choice B. For this problem, we have this segment PQ being graphed on a grid, and a student's going to plot another point, S, somewhere on this segment, so that the distance between S and Q is twice the distance between S and P. We want to figure out what the coordinates of this magic point S would be, and we've got 4 choices here. So you could test out the distances on all 4 of these choices, but I'm actually going to graph these first and try to pick the one that's the most likely to be correct. Although they didn't say it, it looks like this graph is drawn to scale. I mean, this is a nice grid here. So let me eyeball this first and start with the most likely candidate. So A is at -1, -2. There's one option. B is at 0, -1/2. C is at 1/2, 0, so pretty close to B. And then D is at 2, 2. So taking a look at all of these, I mean, the distance from my point to Q is supposed to be twice the distance that my point is from P. Looking at D, D looks like it's half the distance from Q that it is from P. So D looks like it's not going to be it at all. B and C, those both look like they're roughly halfway. Definitely not exactly halfway. They can't both be at the midpoint, but they're pretty close. So I very much doubt that the distance from B or C to Q is going to be twice what it is to P, even if it's a little bit longer. Now the distance from A to Q looks like it's going to be twice the distance from A to P. It's likely, but let me double check and get the numbers just to be sure. So let's check A first, and if it turns out not to be true, then we'll try B next, and then C, and then D. So how do I find the distance, firstly, from A to P? So we could use the revved up distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. But that's really just Pythagorean theorem. So if we just think of this as like the third side, the hypotenuse of a right triangle, we have sides of 3 and 4 for this right triangle. So if I do the square root of 3 squared plus 4 squared, or I just think of that famous right triangle that has 3 and 4 as two of the sides, we're going to end up with the square root of 9 plus 16, square root of 25, which comes out to 5. Or you might just remember this is a 3, 4, 5 right triangle. Now how about the distance from this point here all the way to Q? Well, again, kind of using our Pythagorean theorem, we can do, let's see, the base here looks like we have 6 for the base of the triangle, and this is 4, 5, 6, 7, 8 for the height. So we could do square root of 6 squared plus 8 squared. That's the square root of 36 plus 64, which is the square root of 100, which is 10. Or again, this is basically a 3, 4, 5 triangle, except all the sides have been multiplied by 2. In any case, we see that SQ is twice what SP was. So that proves that choice A is in fact the point that we want. For this couple of questions, we're going to be using this chart here that has different types of vehicles that were for sale. One row here shows the color of the vehicle, and then we have vans versus trucks and the totals of each of these things. So, based off the table for the first part of the question, we want the percentage of vehicles for sale at the dealership that are trucks, and explain how we got the answer. So we need to take the total number of vehicles that are trucks and divide that by the total number of vehicles overall at the dealership. So total trucks divided by total. Total trucks is right here. It's at the end of the truck row. That's 189. And the overall total is down here in the corner. That's 420. So we have 189 divided by 420. And they said they want a percentage, so let's divide that on the calculator. So if we do 189 divided by 420, enter, that comes out to 0.45, which is equivalent to a percentage, if we move the decimal over, of 45%. For the next part of the question, they want to know what fraction of the vans for sale are blue. So for this one, we have to be a little careful. We don't want to use 420 as the denominator again, because that would be the fraction of the total vehicles that are blue. We want to use just the total number of vans for our denominator. And then we just want to use the blue vans for the numerator. So we have blue vans divided by blue total. Actually, no, I should say blue vans divided by total vans. So that would be 127. That's the blue vans divided by the total vans of 231. And you can try it on the calculator, but this one can't really be reduced, so we're going to leave it as that. For this one, we want to know what fraction of the vehicles at this dealership are red or are vans. So we need to take the red vehicles and or at least the percentage, the fractional chance of getting a red vehicle, and then add that to the fraction for vans. So let's deal with red first. We have a total of 115 red vehicles out of 420. So we can write 115 over 420. And next, let's get the fraction of vehicles that are vans. So we have 231 vans overall out of 420 vehicles, so 231 over 420. Now we have to add these fractions together because this is an OR statement. So OR gives you more. You have to always add those. Adding these together, we end up with, let's see, we're going to have 346 over 420. And I believe they're going to want you to reduce this fraction if possible. You can reduce this to 173 over 210 and cannot be reduced further, so we're going to call that one done. On this last part of the problem, they want to know how many of the vehicles for sale are vans and are either red or green. So basically, we're looking for red, the combination of red and green vans. Now, one thing you have to be careful about here is they just said how many. They didn't ask what percentage. They didn't ask what fraction. They just said how many. So we don't even need to do like a probability fraction sort of thing. We can just take the raw number of vehicles and add them together. So first off, we need vans that are red. So red vans, there are 53 of those. And now green vans, there are 51 of those. So 53 and 51 added together, red plus green added together, gives us 104 vans, and that's it. Not much else to do there. For this problem, we have two students calculating the area of a circular skating rink with a radius of 20 yards. First student calculates this using 3 to estimate pi, and the other one uses 3.14 for pi. So we want to compare these calculations and figure out who's more accurate, the first or the second, and by about how many square yards. So probably a good way to start this would be, since we're allowed to use calculators, figure out the true value, or at least a closer estimated value of the area. In general, we're using the formula area equals pi r squared. So for our true area, that's going to be pi, the actual pi, times 20 squared. And I'm going to do that on my calculator now. Now to do this on the calculator, I'm going to do the pi button. So for my calculator, that's a second exponent button, but it might be something different on yours. Most scientific calculators have a pi button in there. And then we're going to multiply that by 20 squared. So 20 squared. And then that's coming out to approximately 1,256.64 if we round that off. We could go a little further if we wanted to. Now for the next area, using just 3 instead of pi, so this would be 3 times 20 squared. Well, I kind of know that one even without the calculator. 20 squared is 400. 400 times 3 is 1,200, so that's definitely way off. For the second student, we're using 3.14 instead of pi. So let me go back and put that exact thing on my calculator. So I've got 3.14 times 20 squared, and enter. So that comes out to exactly 1,256. So it looks like the second student is definitely closer to the correct answer here. And by how much? Well, the second student is less than 1 unit away, 1 square yard away from the true answer. The other student is roughly 56 or 57 away. So we'll call that, given the answer choices here, we're going to say about 56 square yards away. On this one, we are given a triangle, and we want to figure out the value of this p side over here. So what we've got here is an angle, and we also have the side that's across from it. You could try this using some SOHCAHTOA, sine, cosine, tangent kind of stuff, only some of these answers are in radical form, and SOHCAHTOA doesn't really work that well for that. That's more of a decimal kind of answer. But we do notice that this is 30 degrees and 90 degrees. That means the other side must be 60 degrees. The other angle has to be 60. So this is actually one of your special triangles, the 30, 60, 90 triangle, whose sides, which you can get this right off the reference sheet, are in a ratio of side to side radical 3 to 2 times the side. And it might be different variables on the sheet, but that's what it boils down to. So to figure things out here, I like to label each side of my triangle with one of these S expressions. So the just S by itself, I always put that across from the 30 degree angle. So that's right here. S root 3 I put across from 60. So that would be over here. And then the 2S, I'm putting that across from the right angle, the hypotenuse there. And in order to figure out any of these sides, you need to figure out the side that they actually gave you a number for and set that equal to whatever S is there. So I see here that S corresponds with this 15 millimeter side. So that means S is 15. Now, what does P do? How is P related to these S expressions? Well, P is the S radical 3 side of this triangle. So since P is going to be whatever S is times the square root of 3, and S is 15, that means P must be 15 radical 3, which is answer choice B. On this one, all we had to do was match up each of these definitions with the term that it goes with. So I'll just go from left to right here. The set of all points equidistant from a point in a plane, that would be a circle. Circle goes the same distance in every direction from its center, that distance being called the radius. Next, we have lines in a plane that do not intersect. Non-intersecting lines, that's going to be parallel lines. Two rays that have the same endpoint. Well, between angle and line segment, I'd say that angle makes a little more sense. The endpoint is the vertex of the angle, and the rays are the two legs of the angle. And then line segment, this matches the part of the line that contains two endpoints and all the points in between them. The endpoints is what makes this a line segment. So there we have it. On this one, we have a triangle, TUV, on this plane here. And they're telling us they're going to first reflect it over the x-axis and then translate it 2 units up and 1 unit left. They want to know the final coordinates of point V after these two transformations. So one thing I want to get straight right at the get-go here is I'm not moving this whole triangle around. All they care about is where V ends up. So I'm just going to do these two transformations on point V and not worry about anything else. So first transformation, we're reflecting V over the x-axis. So over the x-axis brings us here, down at 5, -2. Next, we're going 2 units up and 1 unit left from there. So here I am, 2 units up, 1 unit left. That brings me right there at the point 4, 0, which is choice B. For this particular problem, we're using this diagram just for part A. It's a multi-part problem, but this only gets used once. So we want the volume of this cylinder here. In general, our volume formula, which you're given on your reference sheet, is going to be pi r squared h for the volume of a cylinder. So plug in some things in here. We're going to have pi times 6 squared, that's our radius, times this height here of 15. And they wanted this to the nearest cubic inch, so we'll just plug this in the calculator. So there we go. My calculator has a pi button, but if yours doesn't, you can just use 3.14, and that'll get you close enough. This should come out to approximately 1,696, and that's in cubic inches. For this part of the problem, we are given 3 new cylinders, X, Y, and Z, and some measurements. We just want to compare the volumes of these 3 cylinders and figure out the volume of cylinder Y. Is it greater than, less than, the same as the volume of cylinder X? And we also want to compare cylinder Z to cylinder X. So first, let's figure out the volume of cylinder X. So again, we're using pi r squared h. So in this case, we're going to have pi times 8 squared times our height of 14. And let me put that in the calculator. So there we go. Let's press enter on that. Comes out to about 2,814.87, some change. So we'll call this 2815 just to round it off. Now we're going to figure out the volume of cylinder Y. So we're going to have pi times our radius, which is still 8, so 8 squared, times, now the height is actually this height of 14. So that is going to come out to exactly the same thing we had before, because we just did literally those numbers on the calculator. So we can say then that the volume of Y is the same as the volume of X. 2815 equals 2815. And this kind of makes sense if you think about it. Let's say that cylinder X was basically like a stack of pancakes, and then somebody knocks the same stack of pancakes over a little bit so it's tilting, but we still have the same amount of pancake in there, right? Just because it's leaning, that doesn't change how many calories that's going to be if you eat all of those at once. Anyway, moving on to cylinder Z, we're going to do pi times 14 squared this time around, new radius, times a height of 8. And let's go ahead and plug that in. So pi times 14 squared times 8, that comes out to a lot more than we got before, 4,926 if we round that off. That's bigger than 2815, so that tells us that Z's volume is greater than that of X. On this one, we have a compound inequality used to determine X, the range of temperatures in Fahrenheit at which zinc is a liquid. So this is kind of an interesting setup. We want the approximate range of temperatures in Fahrenheit at which zinc is a liquid. So basically, all of this is saying for solve for X using this compound inequality. So the idea here is you're basically going to try to undo all this stuff that's happening to X, but you're going to have to, when you do those inverse operations, you're going to have to do it to all three pieces of this at the same time. And the good news here is that we're not dividing or multiplying by a negative at any point in this process, so we don't have to worry about reversing any directions of inequalities. This is just all straight up the inequality staying facing to the left. So first thing we're going to have to undo is this 5/9. This is the kind of the outermost function going on around this x. So to undo multiplication by 5/9, I can multiply by its reciprocal 9/5. So here's my original expression. I'm going to multiply by 9/5 on all that. So I'll need the calculator for that. So I've got 419.5, and I'm going to multiply by 9, and then divide by 5. And that comes out to 755.1. 9/5 times the 5/9 here is going to cancel, so I'm just going to have x minus 32 in between there. And now I have to do 9/5 times 907. So let me do 907 times 9 divided by 5, which gives me 1632.6. All right, now to get x by itself, I also have to get rid of this minus 32, which I can do by adding 32 to all three places. And again, I'm not multiplying or dividing by a negative, so I don't have to reverse any inequalities. So 755.1 plus 32, that's going to be 787.1. Adding 32 inside here gets x by itself. That's the whole point of it. Over here, 1632.6 plus 32, that's going to be 1,664.6. And now hopefully that's one of our answer choices. It is choice C. For this free response problem, we have Michaela saving some money to buy a laptop computer. She's already got $150 in her savings account, and then she's going to have a tutoring job that pays $10 an hour, and that'll be added to her savings account. So for the first part of this question, we want the total amount of money Michaela will have saved after tutoring for 12 hours. And how did we get that? So we've got her savings, that's $150 already in there, and then we're adding $10 per hour. So I'm going to do 10 times the number of hours, 10 times 12. That's 150 plus 120, which comes out to $270. For this next part of the problem, we want an expression representing the amount of money Michaela has after X hours. So we're going to set this pretty much up like we did before, just 150 plus 10 times the number of hours. In this case, we're going to have 150 plus 10 times X hours, where now we can plug anything we want in for X, but this represents all of the possible amounts of money that Michaela could have saved. For this part of the problem, we're told that the least expensive laptop Michaela is considering is $550, which includes tax, conveniently. We want to write and solve an inequality to determine the minimum number of hours Michaela needs to tutor to have enough money to purchase that $550 laptop, or more. So show or explain how we got the answer. So to start this one off, I'm going to take the expression that we just wrote representing how much money Michaela has after X hours. So 150 plus 10X, and we want this to amount to at least $550. So that means that whatever this comes out to, it must be greater than or equal to 550. So that's the inequality that we now have to solve. So I'm going to subtract 150 from both sides. That'll give me 10x greater than or equal to 400. I'm not dividing or multiplying by a negative, so I can keep my inequality facing the same direction. And then here we've got 10 dividing into both sides, so we'll have x greater than or equal to 40. So 40 hours then is the minimum number of hours that Michaela needs to tutor. For the last part of the problem, we're told that the most expensive laptop Michaela is considering is $1,150. This time we want a compound inequality to figure out the number of hours she needs to tutor to have enough money for that minimum cost laptop, but not more money than the maximum cost. So we will start again with the expression for how much money she's got. That's 150 plus 10x. And now that all has to be greater than or equal to 550. So I can also write that as 550 is less than 150 plus 10x. And now my 150 plus 10x, we don't want that to be more than the maximum cost of the laptop. So we'll write less than or equal to 1150. And now we just have to go ahead and solve this. So let's see here. We've got 150 getting subtracted from both sides. So 550 minus 150 is 400. We actually did this already. We've got the 10x in the middle as well, because that's the whole reason we're subtracting 150. So we've got 400 over here on the left. On the right side, this is going to be 1,000 now. And then if I go ahead and divide everything by 10 to get x truly by itself, I've got x in the middle, 40 on the left, 100 on the right. So that means Michaela has to work at least 40 hours and no more than 100 hours to get the laptops that she's considering. For this one, we've got a parallelogram and this line P down here on some graph. And we have a student reflecting this parallelogram over line P to create a new parallelogram. We want to know which will be the coordinates of point H. So this is a very elaborate way for saying basically where is point D going to end up. So we're basically just reflecting point D. So let's go ahead and do that. Here's point D. We're reflecting that over the line P. D is 3 away vertically, so we'll just go 3 in the other direction from line P. So this will be point H down here. And that is the point, if we just look this up, -2, -5, which gives us choice A. For this part of the problem, we're using the same parallelogram, but we want to know which sequence of transformations will map A, B, C, D onto itself. So basically, what transformations can I do that will not change the picture at all? It'll basically get us back to where we started. So taking a look at each of these in turn, we have a reflection over the y-axis followed by a reflection over the x-axis. So y-axis would bring us this way, x-axis would bring us down here. Because these are reflecting over a different axis each time, that means that we're going to end up in a different place. We're not just going to go back where we started. So this is a no for that one. Next one is a clockwise rotation 180 about the origin, followed by counterclockwise rotation of 180 about the origin. So just to take an example here, point D, if we rotate that clockwise, that would bring us down here. Counterclockwise would bring us back over here. 180 clockwise, 180 counterclockwise. It's basically the same rotation. No matter which way you get there, you're rotating the same number of degrees, just opposite directions. So because these are opposite directions and they're by the same amount, these are essentially going to cancel each other out, and you are going to end up back where you started. So this one's a yes, and we could pick B if we wanted right now, but just to be on the safe side, let's look at the others. So C, reflection over y-axis, followed by a clockwise rotation of 180 about the origin. So just looking at point D here, if we flip this over the y-axis, it brings us over here, and then a 180 rotation brings us down into the bottom left, which is not going to be the same place we started. So since we're ending up in the bottom left and not the upper left, that means this is a no. And then this last one, a dilation by a factor of 5, followed by another dilation with -5. Multiplying by 5 and then multiplying by -5, those do not undo each other. If we were multiplying by 1/5, that would be a different story. But this ends up giving us a total dilation of -5, which results in just a bigger shape than we started with. So this is also a no, and we can confidently pick choice B. For this problem, we're representing line Q with y equals x, and then point T is going to be reflected over this line. All we have to do is basically just plot the image of point T, which we'll call T prime, on this plane. That's it. So I'm going to draw the line y equals x first. That's a line with a y-intercept of 0 and a slope of 1. So it's starting here, up 1, over 1, up 1, over 1. It's this line right here. I'll draw a dashed line just so I don't think it's a real line. And then I just need to reflect T over this thing. So we are diagonally 2 diagonal units this way. If I go 2 diagonal units in the other direction, that brings me here, which I'll call this t prime, and that's all I actually had to do on this one. On this problem, we are giving these parallel lines, K and J, and this triangle in here with all these different angles. We want to know which of these statements would prove that angle 1 is congruent to angle 4, and then that angle 3 is congruent to angle 5. So a helpful thing to notice on this is that 1 and 4 are alternate interior angles with respect to each other, and 3 and 5 are also alternate interior angles. And this is why you kind of need to know these terms and definitions, because that's all of what they're talking about in these answer choices. So let's identify the answer choice that talks about these alternate interior angles. So choice A, we're talking about vertical angles. That doesn't seem to have anything to do with alternate interior. Choice B is about corresponding angles, still not alt-int. Choice C, alternate interior angles formed by intersection of a transversal of 2 parallel lines are congruent. Well, this at least has something to do with alternate interior angles. And then finally, choice D, measure of an exterior angle is equal to the sum of the measure of the 2 opposite interior angles. This is talking about 3 sets of angles, a set of 3 angles versus a set of 2 angles. So D doesn't seem very likely either. So definitely choice C is the best pick out of that batch. On this problem, we have students raising money by selling t-shirts, and they ordered 100 of these to sell for $20 each. And here's a nice little equation that models all this. We want the domain of this function, where n is a whole number. So domain is the inputs. So basically we're asking, if you start plugging in different n values, different numbers of t-shirts sold, kind of what's the lower limit on those, what's the upper limit on those? What's the least number of t-shirts we could sell? Well, we could sell 0 t-shirts if we were really bad at selling these things. We can't sell less than 0. So 0 is kind of the bottom level of how many t-shirts we can sell. Now, for the max number that we can sell, we can't sell more t-shirts than we've ordered, right? Unless we're making them ourselves. So since we ordered 100 t-shirts, that's the most that we can possibly sell. Can't sell more than that. So we would then say that our domain is going to be between 0 and 100. N is going to be between 0 and 100, so choice B is where it's at. For this one, we've got a few problems based off of this table, which just you'll note is not complete yet. So we have a teacher surveys the students about whether they play a sport and play sports-related video games. And this is the table breaking it all down. So we have one column here talking about, or these different rows are talking about whether or not we play the video games, and the columns are talking about whether or not we play an actual real-life sport. So based on the table, for part A of this question, we want to know how many students at the school play sports-related games, video games, but don't play a sport. So basically, we're looking for this empty box right here. Now, the key on this is understanding that as we move to the right, this total column here is the sum of the numbers further to the left, like 165 plus 278 adds up to 443. That's how we got that 443. And then 110 plus something equals 294. So to figure out what this something was, we just have to do 294 minus 110, which you can use a calculator if you want. That's going to end up being 184 students. For this next problem part, we want to know, given that a randomly selected student from the school participates in a sport, what's the probability that student also plays sports-related video games? Not sure if I need it, but I'm going to just write in the 184 into my table. I may or may not actually need it, but it just feels weird not having it in there. So here's the key wording. Given that a randomly selected student participates in a sport. So this is telling us right away we're only allowed to consider the students who participate in a sport. So that's this whole first column here. None of this other stuff matters, just given that somebody actually plays a sport. What's the probability the student also plays video games? So we have a numerator and denominator for our probability. The denominator is going to be the total number of students who actually play a sport, so 275. The numerator is just going to be the ones out of that 275 that also play video games, which in this case is 110. We could reduce this. However, looking at the answer choices, there's already an answer choice that's this number, so we're just going to pick choice B. On this one, we have a circle with different points on it, and we're given that QS is the diameter, which is kind of important. R is the center, and we're also given the measure of angle Q is 54. Based off of all this, we want the measure of angle S. Now, there's really two big ways to figure out the measure of this angle. One is to figure out the measure of angle P, and then use that and 54 to get S. Another would be to figure out the measure of arc QP, minor arc QP, and then take half of that to get the inscribed angle S. I went for the first approach. I'm going to figure out P, and that'll help me figure out S, but the other one works as well. So the key on this one, P is going to be, angle P is going to be half of the arc that it intercepts, this arc QS. Now QS, since this line here, the line QS is the diameter, that means that arc QS is exactly half the circle, which means that that arc there has 180 degrees. So this is half of 180, which means that angle P is actually 90 degrees. So it turns out we had a right triangle this whole time and maybe just didn't even know it. So to get S, all I have to do is add 54 and 90 together and subtract that from 180. So 54 plus 90, that's 144. 180 minus that is 36. So that'll give us choice B, 36 degrees. On this problem, we are trying to figure out, based off of this table, that on average, our function is either increasing or decreasing, and how much it's increasing or decreasing by for every unit you move to the right. So probably the easiest way to do this is just to use our average rate of change kind of formula. So f of x2 minus f of x1 over x2 minus x1. It's not on a formula sheet anywhere, but this is basically your slope formula, y2 minus y1 over x2 minus x1. So in this case, I'm going to be doing f of 2 minus f of negative 1 over 2 minus negative 1. So f of 2, that's going to be negative 2.7, and I'm going to be subtracting 8.1. That was f of negative 1 up there. That's my first y value. And then down below, I've got 2 minus negative 1, which is going to actually be 2 plus 1, or 3. Let me go ahead and do this on the calculator. So first, let me do my numerator. Negative 2.7 minus 8.1 comes out to negative 10.8. And then I'm going to turn around and divide that by 2 plus 1, which is 3. And that comes out to negative 3.6. So I see 3.6 in this drop-down menu, which means I'm going to be picking that. But I also have to decide if my function is increasing or decreasing. Since we have a negative rate of change, that means that my function values are going down, and you can see that just by looking at the table. So I'm going to say that we are decreasing by about 3.6 unit per 1 units. For this problem, we've got a big old trapezoid on a coordinate plane, and we're trying to get the perimeter of this trapezoid, which is to say the distance around the trapezoid. That means we're going to have to calculate the distances of all 4 sides, and I'm just eyeballing it, but they all look like they're probably different distances. And then we'll just add them together. So I'm going to start up here with HE. Now to get this distance up here, I need to basically use Pythagorean theorem. I can think of this as like a hypotenuse on a triangle with one side is 2 and the other side, this is a distance of 8. So if I do the square root of 2 squared plus 8 squared, that'll give me that distance. Let me do that on the calculator. So square root of 8 squared plus 2 squared, that's all coming out to, these answer choices are rounded to the nearest tenth. So if I take it out to a tenth, I'll probably get close enough to one of these. They're not super close together. So I've got 8.2 roughly that I'll use for that. And then I'm just going to make the rounds here. So EF is pretty easy to see. That's a vertical line, so we can just count the grid lines for that. So that's 3, 4, 5, 6, 7. And now for GF or FG, doesn't really matter, I'm going to use my little Pythagorean theorem trick that I used for HE. So now I'm going to do the square root of, this time around we've got, still have, let's see here, 8 squared for that one side, but now we also have 1 squared for that distance. So 8 squared plus 1 squared. So this actually should be pretty close to what HE was, but let me plug it in. So square root of 8 squared plus 1 squared comes out to roughly 8.1. So not a huge difference. And then going for this fourth side here, this is a distance of how much? Well, we're going from -4 to 6 on the y values. 6 minus -4, 6 plus 4 is 10. So now I just have to add these all together, which I could probably do that without a calculator or with one, either way. 8.2 and 8.1, that's going to be 16.3. 7 and 10 is 17. 16.3 and 17 adds up to, 33.3. That's kind of cute. So that's choice C.